All right, I hope lunch was good. You had a chance, hopefully, to look out in the hall at our some of the work we're doing that we think is relevant, and if not, it'll be there later. Our afternoon panel, I think, was set up really well by Taylor and our morning panel. We're going to explore the opportunities that AI offers, specifically around safety. I mean, that's such a key topic that we thought it deserved the afternoon. Our moderator is going to be our Mcity Research Director, Greg Stevens. And everything I say after this, I promise I'm not referring to myself in the third person. Henry mentioned this morning, Greg came to Mcity after a long career at Ford, a really impressive one too. We started working with Greg when he was still there. He helped Ford found Mcity, as a matter of fact, and he was our executive champion for many years. After Ford, Greg had his own consulting business, and we brought him in to help us think about what direction Mcity should take. You know, we're in our 10th year now, hard to believe, but what we thought 10 years ago and where we're trying to head now, are not quite the same, right? We've grown as the technologies have changed and the opportunities have changed as well. And I don't know how, but the opportunity somehow presented itself for Greg to tackle some of these seed research ideas and turn them into things that we think have value for industry and value for academia and value for our government together. And I just feel very lucky that we've conned you into joining us. And
glad to be here.
Yeah, thanks. So Greg's gonna lead the panel. We'll let him and the panelists introduce themselves. But Greg, take it away. Thank you.
Thanks, Greg. Appreciate it.
Yep.
Yeah, Mcity's been a blessing. So love the fact that Mcity was here for me when I was ready for Mcity, right? So it's worked out as the best of both worlds here. But hopefully what we'll take you through is an interesting discussion here on AI safety, right? And AI safety, particularly in the context of transportation, right? Because the consequences of wrong decisions when you're moving at 70 miles per hour are very significant, right? So the lens of AI safety in that sort of a safety critical environment, I think, is a really important topic for us to be addressing. And kind of a busy slide, but I'll take you through it. You know, we're going to talk about, both the promise and the potential pitfalls of AI, right? Try and give sort of a balanced view. On the upside here, we have the fact that AI models are absolutely taking over, right? You'd have to, be living in a cave not to have heard, how much AI is changing our lives and will continue to change our lives. And a lot of it is because these AI models are performing dramatically better than the more traditional ways we used to write algorithms. And so just that performance advantage, right? The fact that AI models surprise us on the upside and we say, wow, that model actually handled something I didn't expect it to handle, right? That idea of these emergent behaviors has been, really part of the promise of AI. The difficulty is there's also those sometimes downside surprises, right? Where we go, didn't expect it to fail that way, right? We would have thought it would have handled that differently, right? And then when somebody goes and says, okay, so why did it fail? Give me an explanation. What happened, right? You say, well, it's sort of a black box model. It's not like C++ code where you just pull the code up, you read through it, you go, oh, I found the bug. That's why, right? This is different, right? These models are not human readable. They're a set of weights that were determined by an optimizer, basically, right? So you can't read through the model. So in a lot of ways, causality is hidden. And then people say, okay, well, maybe you can't tell me why it failed, but can you guarantee that it won't fail again in that way, right? And then you get in, well, we know where it failed, So we can go gather a lot of training data, we can annotate it, we can retrain our model, but end of the day, it's a probabilistic model, right? It's not a deterministic model. And so, what we can say is we have made the probability of recurrence small, right? But it's not like, again, like we used to do where we say, we looked through the code, we found the bug, we fixed the bug, that's not gonna happen again, right? So this is really part of the challenge. And, in a lot of spaces, the challenge can be handled by, oh, well, let's just reboot the system or something. But transportation challenges are not like that, right? It's traveling at 70 miles an hour on a road with a ton of kinetic energy, right? And so the real question that I want to get at here is at the bottom is, how can we leverage the power of AI in automated driving while also guarding against the hazards created by its seeming unpredictability? And I have a great panel to help me with that. And what we're going to do next is give everybody, we'll just roll down the line, but give each of them a chance to introduce themselves, tell us how you're using AI in your world, and how AI safety, if you have sort of any viewpoints on that you wanted to share as sort of like an opening comment. So we'll start with Prasad.
Thanks, Greg. Thank you, Greg. It's a real pleasure to be here and share some of my thoughts. Just a little bit about myself. I work at the Center for Automotive Research. I have met some of you here in the audience. The work we do at CAR is at the Venn diagram intersection of policymaking, public interests, and private sector investments and all the risk-taking that happens. And so, broadly speaking, technology is at the key of and center of all this. However, we look at technology from the standpoint of the impact technology is having on labor and economics and policy, and the impact that technology is having on fuel efficiency or overall clean energy transitions and associated sustainability questions. So that's sort of a broad context of what we do at CAR. And then in the context of safety, there's been some really fascinating discussions that have come to us. We tend to get public policymaker questions, we get private investor questions, and one that's come that's sort of a broad canvas view has to do with sort of the two dimensions, where on one dimensions we have roughly upwards of 3 trillion with a T million miles of vehicle miles traveled in the United States. And on the other dimension, there's upwards of 40,000 annual fatalities, as we know. So if you look at that dimension, that spread there of 40,000 plus fatalities on highways and 3 trillion, more than 3 trillion vehicle miles traveled, there's a lot of opportunity there for just about every aspect of what we can do to bring that number down, the 40,000 plus fatalities down to zero. And so naturally there's AI that's there as a powerful tool, and it sort of comes to us in 3 different forms. One is where humans are basically pretty good at doing something, but AI and machines can do a much better job in a more or less directly beneficial way. So that's almost like I don't want to trivialize anything here, but that's an immediate opportunity to just understand what those are and essentially make sure that public policy funds that, but also private investment comes and takes the risk needed to make that really good and valuable to society. At the other end of the spectrum are things that human beings are, find hard to do, and machines can sort of, do a lot and gain, but then you need human oversight. You need humans to understand where there might be bias inherently in the solution. So there is this engagement that will always be there for humans and machines to work together. And then there's this in between where humans are essentially inherently better and smarter, and so we have to recognize that, understand how to build that into our thought process. And again, policy making to make sure that educational systems get funded and can still create these thinkers of the future that are really going to shape and determine what needs to happen with AI as a tool. So that's sort of the broad overview of what we do.
Thanks, Prasad. So Prasad will help us with all the high-level strategy questions. Be thinking of your questions as this panel proceeds, because I'll do sort of a moderated period, but then we'll throw it open for audience questions. So CJ next.
Yeah, my name's CJ King. I'm the CTO at Torque Robotics, and we are a L4 trucking company. So we focus on hub-to-hub delivery of Class 8 trucks. We're in partnership with Daimler Truck that Milena mentioned earlier, and so we get to partner and do a lot with them and actually bring that forward. And the focus there is to deliver safe goods on time, reliable. And where we focus at mostly, and a lot of our AI is going to go into the entire AV stack. So not just in perception and sensing and understanding, but really how do we actually drive motion control around that? So it's a little bit different paradigm than a lot of folks are used to in robotaxi or others, because we're taking a 53-foot trailer, putting a bunch of weight in the back of it, has a whole different speed profile, that kind of stuff. So it's a market that's really open because the industry is actually needing more drivers to be safe, because when it is an accident, it usually drives into fatality very quickly just based on physics. And that's where a lot of the topics, and when Greg brings into it, we'll get to share a lot more on that. My background's been across a couple of OEMs on the passenger car side in tech, and then now most recently in this Torque role, driving both the product and the technology to merge that in. A lot of the safety and aspects we can do is around ODD design, and where we focus on that to actually take us out of adverse conditions. And a lot of that is driven by our AI findings, and we'll get into more of that as we go.
Perfect. Thanks, CJ. I told CJ at lunch, I think CTO is the coolest title. So I'm so jealous of that. I have never been a CTO. Maybe I could be the CTO. We should talk. Henry, after this. All right, Ram is next.
I'm Ram Vasudevan. I'm an associate professor of mechanical engineering and robotics here at Michigan. I also am CTO of Refraction AI. So there you go.
Well done. All right.
So my background is primarily around actually safety of autonomous systems and trying to develop algorithms that actually can guarantee safety. I got my start during my PhD at Berkeley, where actually we were working with Ford back at that time. It was actually my first time at Michigan. We were up in Sault Ste. Marie, which if you've never been, it's quite cold. I grew up in Southern California, so that was my first lesson in safety for myself. Lots of jackets. In any case, we were doing lots of high-speed driving and whatnot, and then I, after that, moved on to do a postdoc at MIT where I worked on humanoids and actually part of the DARPA Robotics Challenge. So we were trying to build algorithms to enable humanoids to operate safely in unknown environments and whatnot, and then slowly segued into this role as a professor at Michigan, where my group spends a lot of time thinking about how do you actually introduce safety in a meaningful way. We've done quite a bit of work on actually doing that at the motion planning and control level, but then now we're sort of pushing up to a higher level and thinking more about how do you build probabilistic models and how do you interpret them in meaningful ways to actually say something about safety. So yeah.
Thanks, Ram. And our next panelist has safety in his title. So Satvir.
Hi, I'm Satvir Singh. I'm a Director of Product Safety and Test and Validation at May Mobility. May Mobility is what we call as a microtransit company. What we're really trying to solve, our mission is to reimagination transportation. What we work with cities as our customers right now and try to figure out what are the deficiencies or inefficiencies in the transit today, and we try to close them through a service that we provide. I think if you talk to anybody at May, we play what we call the bus game. So every time a bus goes by, we count how many passengers are in there, and if we can fit it in our car, that's a point for us. And that tells us that there's an efficient way of doing it. Really, we work in a small geofenced. Today, we are at low speed. Service providers. We provide service in university areas like Ann Arbor, Texas, University of Arlington, Texas. But we are also in rural areas like Grand Rapids, Minnesota, Sun City, where we have our first driver out service. It's a retirement community. Average age is about 67 years old, and there is no transportation there. So our goal is to make sure they're able to do things that they want to do, connect them to rec centers, connect them to medical shops, whatever is needed. In terms of AI, we do use classical, for perception. We have our own secret, which we call source for control, which is MPDM, multi-policy decision making, which is, Ed Olson is our I think he's still a faculty here. He never shows up, is what he tells me. And then my goal is, like I tell everybody, my goal is to keep everything boring. I don't like excitement, so no excitement while we're driving. Goal really is to make sure there is a performance wrapper around the AI. There's a safety wrapper around it. So everything that comes out is risk assessed, is assessed for comfort, and the end result is is the minimum risk maneuver, and it's comfortable for our riders. So that's happy to be here.
Thanks, Satvir. Yeah, and I guess when maybe day to day, the job, it may not be the exciting stuff, but when things go wrong, I'm sure your job gets exciting.
Yeah. I try to minimize that one.
Yes, that's good. Yeah. All right, so let's start out, talking about the promise of AI. Maybe we could get some panelist perspective on, where do you think AI in transportation, transportation generally, but also with a safety perspective, where has AI really changed the game?
So to start with, I think the most recent change has been around the generative AI and being able to drive that into a scenario creation for our simulation environments. Puts it and allows us, so it's not just a data collection, it's actually allowing us to take real world data, make sure we can ground truth that, get it connected, and then take those generative AI models to extend them into scenarios we might never see in any of our data collection. So that's already starting to really change how we do our validation and verification inside of our designs and our feedback loops. Specifically allowing us to look at one incident where we might have a capture, and then we'll be able to do 1,000 iterations on that you would never be able to capture, and then extend each one of those another 1,000 times. So it's giving us that many cycles into a simulation to bring a safer product to allow us to see just paths down that cycle that we would not normally get to do with just based on data collection.
I can tag along on that one. So for me, it's just situational awareness is increased so much, right? From a safety point of view, I always look at situations. Is it known? Is it unknown? Does it have a safety risk? Does it have not a safety risk? And what you want to reduce is unknown safety risks. Now you know a lot. You can manage your safety that way. There are things that are still unknown, but like CJ just said, you can use data now to see what you're seeing outside and drive your simulations. But you can also see that simulation and have somebody disturb it in a way that at what point it fails. That lets you understand limit of your systems. You can do a lot of synthetic modeling. You can look at your ODD and say, I'm going to go through this static element with these many dynamic actors. What are my possible conflict points? How can I have a simulation that covers all this? So that's where it has increased a lot. Earlier it used to be how many kilometers you need to drive. Now for me, it's like what kind of coverage you have, at what point your data is starting to settle down, you're starting to see less, edge cases, and then, you can develop your own edge cases. So I think that's where it's been really powerful and exciting.
Okay, great, thank you. Maybe, Ram, we could throw this one your way, because I know you and I have discussed this some, but there's this trend, from where we were with AV stacks that were completely modular, a big stack of modular, AI modules potentially, right? And now we have some companies that are moving into the end-to-end networks. And there's strengths and weaknesses to both approaches, and I'd like to get your perspective on that.
Sure. So context-wise, maybe just to start off, I think there's sort of two perspectives in this world. So one is trying to essentially do end-to-end, which is basically going straight from pixels to essentially the torques that you apply into the system. It's really attractive because in some sense it's like you've removed all of these sub pieces that we have to, as engineers, try to sub-engineer and build out. And in this sort of end-to-end approach, you're just relying purely on data to solve this problem. So there's this technical allure to it, which for a mathematician, they would say, this is a beautiful proof. For an engineer, they would say this is an amazing, or clear, result, because you're just relying on the data to solve this really amazing problem. On the other hand, there's sort of the traditional approach that people have taken to engineering systems, which is breaking them into these subcomponents. So even if you go to our engineering curriculum, our robotics curriculum at Michigan, we think about robotics in these sort of sub-modules, which is, perception, reasoning, planning, control, all of these sort of sub-modules that we think about integrating together. And in fact, I was at a dinner last night where someone was talking about robotics as being the integration from hell problem. And in some way, that is really this modular design problem, which is you're taking all of these sub-problems, sub-disciplines, and trying to integrate them together in some nice way. Traditionally, for historical reasons, we've actually loved that allure of taking this modular approach because it takes all of our historical knowledge of how engineering works and basically just throws all of the difficulty at the integration task. There's a lot of allure there because, for example, if I'm talking about the control problem, I understand when my control algorithm is working well or not well, right? And in fact, there's beautiful results from 50 or 60 years of control theory that can talk about when these algorithms are going to work as designed, how to make sure that they'll work properly, et cetera. On the other hand, the challenge always is I take all of these things that are error prone, I throw them all together, and I need to now understand the errors generated by all of these systems integrated one on top of one another. So this end-to-end approach has been really attractive. A lot of people talk about it. NVIDIA, Tesla, others have been really, love this idea. It's particularly attractive because you don't have to rely on lots of human data generation, human supervision, all of these things. You can just sort of collect lots of data, have it magically labeled, and then essentially get out an algorithm that can solve these really amazing problems for you. The one challenge is, how do you actually verify that that's actually going to work correctly? And in fact, it sort of trades one problem for another problem, which is now I don't need to worry about all of these different systems integrating with respect to one another. But now I have this other much harder problem, I'd argue, which is a black box that I need to now understand if it's actually going to work well or not. Yeah.
Good, thank you. And maybe Prasad, we'll start with you on this next one, but I think maybe most of the panelists probably have a point of view on it, which is, these models are black box and non-deterministic, right? And in a society that we live in where people want to know why, and they want to know how can you prevent this from happening again, how do we address those challenges?
Well, thanks, Greg. I think this is a very, very relevant question, especially in a world where AI is a powerful tool that's being used as we speak around the planet in a very different context. So 8 billion of us human beings are being surveilled one way or the other by AI, the power of AI. And by that I mean, fundamentally our behavior is being observed. And so it's, I think, a really good opportunity now to understand human behavior and contextual behavior and be able to sort of factor that into the rest of the machine, behaviors that we are trying to program in. And so I think fundamentally, a good system, a system that is compatible with humans, is one that can understand human behavior and interact with human behavior. And so even in the context of AVs, you're going to have humans out on the road, these silly pedestrians or bicyclists who seem to come in the way, or perhaps even a stationary pole. I think fundamentally there's a behavior understanding that can come through the use of AI in the context in which a lot of our vehicles are being designed and being used now and tested. So I think what we're getting to is a place or a point in time where at the asymptotes of what we're trying to do, or the estimations of functions that we're trying to do, we are now, as we get to scale, we are magnifying the gaps that we have in that approximation of the real world scenarios. And whether we call them edge cases or corner cases where two edges meet, I think there's perhaps a very interesting set of opportunities to be able to quantify those by understanding behavior and interaction between human behavior and systems.
And each of the three of you are putting systems into production in some form, right? So what's your thoughts on how to deal with sort of the black box, non-deterministic nature of AI algorithms?
I mean, it's not an easy one, right? And that's why you see a lot of these systems come under scrutiny, or a lot of the headlines in the media. It's a lack of understanding. I think in general, the public doesn't trust a computer or AI that generates that. If you even go back and we just went to heuristic-based algorithms, that still was a problem as we got more complex. A lot of these systems and recalls that were coming were based on our are gaps in pure determinism. They were deterministic, but we didn't always catch where the failures or the faults were. So as we go forward, this is why our company is focusing on a compartmentalized one, is so we can actually break it down to a smaller, let's call it a smaller black box that allows us an easier education process, an easier chance to be predictable. So it's really tied to predictability. So whether you send in all the same data in a different sequence or you send in slightly different data, we need it to behave in a predictable way, which is what we as humans tend to do when we're doing the driving or any of that. It's the predictability of how the system will respond and getting the scenarios. It really comes down to the scenario generation to, as Prasad mentioned, remove the edge cases or corner cases to say that we have enough coverage or enough understanding that says we will operate in a safe, respectable way that allows our product to behave as we would expect a human to behave, or actually more safe and better because we have a lot more information on our hands than a typical driver would from all the different sensors and all that stuff that we can actually realize and understand what's going on from a full motion control all the way out to perception and seeing in different directions and that. So it really comes back to predictability tied into our scenario understanding of the situations we get into.
Sure.
Please go.
Yeah, so I wear two hats. So one is as a professor, and one is as a CTO of a company in this space. So as a professor, the thing I would say is it's a mistake for us to worry about understanding what this black box is doing. So let me give an example, because this seems like a controversial take. I am a terrible engineer. I tell my wife this. She's a fantastic engineer. I'm a really bad engineer. I don't understand how a car works. I mean, I turn my key, the car moves. It's amazing. In theory, I understand how a car works. In fact, I teach a course on how a car works. So in theory, I understand how it works. But in practice, if you ask me to stare at a hybrid engine and explain all of the details of how it worked, I would probably be in a really bad position. And dare say, seems like a smart audience, a lot of people wearing suits. Probably none of you truly understand how an automobile works. Maybe a rare exception does. But nevertheless, you trust that the automobile works. And really, there's something there that actually is telling a much better story. As an academic, we really want algorithms to be able to address the problem of if this algorithm is actually going to work properly. So we need a system of systems that's actually able to intelligently solve the question of, hey, this is actually going to work correctly and verified to work correctly. We don't really care about how that algorithm itself works. We just want that algorithm that knows how to check if that algorithm is going to work. And what I'd say is that as an academic, there's many different ways to think about that. There's sort of the traditional way that engineers have done, which is quantify uncertainty of these different submodules and then think about integrating them together. And that's the corner case, edge case story. The other option is to take a much more statistical approach. And there's a bunch of smart machine learning folks who are thinking about that kind of thing and thinking through the theory of how you do that well. And as an academic, that's what we spend a lot of time thinking about. I think it's really excellent theory. Is it ready for prime time? Certainly not, but that's why I have a job. As a CTO of a company, I would say the thing that we spend a lot of time doing is relying on human supervision. So we've done, I think, 100,000 deliveries, most of them now without actually having a chaser following the robot around. But we have a teleoperator who's definitely keeping an eye on this thing. And we've solved a lot of the safety issues there by removing the size, or like reducing the size of this thing and removing the speed, or reducing the speed of this thing. So it's not traveling at 70 miles per hour, it's traveling at 8 miles per hour. And it doesn't weigh 3 tons, it weighs 30 pounds, right? And so that removes a lot of the risk in that instance, and it makes us feel more comfortable about operating this kind of thing reliably. And in fact, if you look at Waymo, so in fact, Ars Technica had a really beautiful article over the weekend about how does Waymo versus Tesla think about safety. Take a look. They have a human operator who's keeping an eye on their robots as well. So it's not a crazy idea. They're leading the world here in terms of driving humans around, accomplishing things, and they still have a human being sitting and keeping an eye on these things. So it's not a surprising result. They have a lot of AI. They have smart AI people working there, but they're thinking hard about safety, and they rely on a human being really to back solve for that.
I think I have a similar take, but I think you have to complement it with smaller modular testing. So what I always go about is it's called a Swiss cheese model. If you look up, really you have a Swiss cheese slice. It has a bunch of holes, and you can stack them in layers. And for a accident to happen, a failure has to propagate through all the holes. But you also want to make sure your holes are small and you know what your holes are. So you have to test those individually to understand what those are. And this is where you have to define criterias for individual layer, what it means to be safe, what it means to be, it's going to be uncomfortable, it's going to provide a bad perception of safety, because that is one thing that we also deal with as a service provider. I can be perfectly safe, but if I'm driving jerkingly, somebody looking outside or riding it will not like it, right? So that's another layer that we have to do it. And then you have classical layers of, do I have the right embedded system? Do I have the right platform? And then you're using your black box testing as well to say, okay, I fed in this, my answer was this. So for me, not there yet. So that's why we have to have a Swiss cheese model, and that's what we focus on, and that gets you to the understand what your performance is, and that is what you can go tell. What we tell our customers today is like, we can drive within this ODD. These are our constraints, and these are the type of failures that you can see, and these are the failures that we train our safety operators on, so they know what to expect, when to take over, because we have not completely solved it everywhere. We have solved it in very small ODD right now, and it's for limited time when we do it. But I think that's the whole idea, is just to be more open about your issues, more understand, and for that you have to spend time testing your system to understand what your limits are, and then you need to have that open conversation. And I think that's where it's been helpful for us, is our customers have been transit companies, so we can talk to them, we can learn a lot from them, because they've been doing transit longer than we have, right? So, and they once they understand, they know how to get to the users as more than us. So they work with us, which is a great thing for us. So I think it's just transparency and just being open about it, but you have to test it to know yourself first.
Good, thank you. Yeah, I love the Swiss cheese model, that multi-layer defense, right? You can get through one set of holes, but you can't get through the next set or the next set, right? So, yeah, it's a really good model. So there's some really interesting trends in the automobile industry these days. Vehicles are becoming software defined, where they used to, many years ago, be sort of purely hardware defined. And that gives us the opportunity to radically change how the vehicle performs, by changing software. So there's pluses and minuses to that, right? If you make really good radical changes, it's a plus. If you don't, it's a minus, right? And we also have the ability to do those updates over the air, so we can do them more frequently, which again keeps product fresh, but probably also creates lots of verification load to make sure that those frequent updates are good. And we have the ability that, since all our vehicles are becoming connected, right, to put triggers on those vehicles and have them send back interesting events, right, that we can use to make our software better. And so, in the context of these AI models that we're going to be rolling out, how do we take advantage of the upside of these trends? Maybe start with you, Prasad, and manage some of the downsides as well.
Yeah, I think it's the enormous amount of data that's been already collected. Just taking a look back and seeing what of that can be used now to in a holistic sort of systems sense, be able to use the power of AI. And so what I mean by the system-to-systems context here is really the vehicle itself, the vehicle in the context of roadways, and roadways in the context of all this human interaction on the roadway. So it's that whole set that can come together in, I think, ways in which we couldn't have visualized before. And that would then help us with a better overall system design.
Good.
Yeah,
Thanks,
thank you.
Prasad. So software-defined vehicles, data harvesting, OTA updates. Any of the rest of you?
I mean, it's big. Like, if you look at the entire industry, it's not just in an AV stack or any of that. It's a completely different change of where we're all going, and the compute that's going into cars or trucks or any vehicles today is dramatically different than even 10 years ago. Campaign management, meaning how do you actually get the right data at the right time so it's not having to go through. And in the beginning, we just collected everything, and then everyone wanted to go through and sift through that. So that's not efficient to find the needle in the haystack type mentality. But really, how do we find the right triggers? And we're using a lot of that. We use a lot of AI to do predictive modeling on what is actually a relevant intake to us as something that's new, that's not defined, that we haven't seen before. And this is how we break down our scenarios and definitions to allow us to, in real time, we're doing an analysis of all the data that's being collected to see how does that fit into our current and existing scenario understanding, so that way, hey, we're flagging this to say it's very interesting, pull that out, and how do we validate that and then turn that into an opportunity to take synthetic data and grow it in an area that we may have not seen before. It's a little bit different approach than traditionally what a lot of companies have been doing. So I'm not asking to put 1,000 trucks on the road. I'm asking to find the data and then figure out a way to expand and understand it in a way that we haven't done before. So I think that's, as you get more of that, we can do that on any type of vehicle, whether it's a passenger car that we partner with, but finding those unique scenarios, because right now the most unique thing we see is when we get dash cam footage of someone's phone or something, and you're like, wow, we never would have expected that a deer fell out of the sky from a tornado and landed right in front of you. That's not a trajectory of a deer falling from the sky. But we have video of that happening, or getting struck by lightning. Like, all those things happen, and being able to start to take that and extrapolate that out is, I think that's a huge difference on how we think about big data problems now and building out our data lakes versus in the beginning we try to just collect everything. So I see that really starting to change over the next 3 to 5 years in all collection across all vehicle platforms.
Yeah, I think it's even similar for us. Like, the learning never stops. As you are providing service, you're going out there and you're looking at every drive that happened, and you have triggers built into your the log that gets generated to see, okay, these were the leading causes, these were the lagging causes from a safety point of view, and then how can we turn it up into a situation that could become an actual incident. So that becomes very critical. We do a lot of. It also helps us make sure that the new change that we're pushing can be tested against what existed. So you can now also generate, think it of, a KPI, like, I used to have this many unintended heartbreakings. Like, I want to make sure the next software release that happens doesn't cross that metric, right? That tells me something is not working. So you're generating all these data that you already have, you're breaking them down, and you're creating and expanding your test scenarios. And in terms of managing it, like, for me, it's always 3 pillars of safety. You engineered it safe, you build it safe, now you have to operate it safe. That means, when you're putting it out there, you have to make sure the software that goes out is tested software. So but these are, I think, for any software update that we used to do. Now it's just over the air. It does add more complexity to it, but I think it's the same process, at least, that we have to follow.
Okay. So let's talk about development, testing, validation of AI systems, right? Because when things were written in C++ code, you could have a code review, right? And everybody could look at the code. And that's different now. So maybe thinking some on how that's changed with AI, and then also sort of addressing what always is the elephant in the room, which is, how good is good enough, right? Because we do all this development and testing, and we achieve this level in all our metrics. And as technologists, we say, I think this is good enough. We haven't had enough guidance from regulatory or even judicial channels, really, to tell us. And so, how do you deal with that specifically, and especially in an AI context?
Should I take a first crack at it? So, so it starts with the development, like you talked about, and I also talked about the Swiss model, where you're basically testing everything to understand your limits. The other aspect of that is you have to understand what's happening in your ODD. Like if I'm driving in a certain area, what are the ODD elements that I see? What are the static elements? What is a intersection, left turn, right turn, traffic lights? What do I see? What kind of dynamic elements do I see? What kind of VRUs? What is the object that I see? And what is the frequency? What is the distribution of that? And it's very critical to match the distribution of that, what you see out in your ODD to what you have in your test suite. And then you have to come up with certain safety criteria, which could be driven from, I have a fleet size of X, driving for Y hours. That means I do not want to have any safety incident for this amount of time. And we are using what I'm used to, classical failure rates that we have assigned to it. And that is helping us define, do I understand the risk? Like Milena said, you can never eliminate the risk, but you do not want unreasonable risk. So it's essentially understanding your service hours, you're understanding what your safety incident possibilities are within that, and then making a decision on that, and then having a loop back into your to make sure you're constantly updating it. It should not be a fixed threshold for you, because if you learn something, you have to adapt to it.
Yeah, maybe let me press a little bit harder,
Sure.
because you're running autonomous shuttles in Sun City without safety drivers,
Yes.
right? So how do you make that decision to say we're okay running without safety drivers?
Yeah, so it actually started at Mcity. We started.
Well done.
We did a one year of testing of almost driver out with staged scenarios that we wanted to see our vehicle to react. And parallelly, we were running almost a year and a half of service in Sun City on a larger ODD, and that's where we were gathering data to see what our safety performance was. And at the end, decision we made was, it is not the complete ODD, it's not complete service hours, so we have limited it to ODD elements to a service hour where we do not see any safety incidents, even in, because that has low agent count right now. That's the first step for us. So has helped us get driver out in a very constrained amount, and now we're continuing to collect data, and as we see our performance get better in higher densities, more complex, we will take another step towards it. But it really was to what our performance was within that time frame, within that ODD. And we have right now very strict scouting process to make sure it does not go out of ODD, because that's where we have not completely safety verified it. And as we increase, I think we will expand it more.
So rigorously validating within the ODD and then monitoring to make sure you don't go outside the ODD.
Yeah. We have a remote operator as well that's always monitoring the car. So.
Okay. Others want to chime in?
So going back to the original question before you dug in, maybe a little bit, I think there's two answers that you asked, two questions. And the first one is, how do we test and what are we doing there? And how do we prove that, A, the new model's better, we've enhanced the performance. So really focusing on breaking down, it's a black box. And when you have a black box, your interfaces are very critical. So what are your expected input to output, whether it's a ratio, performance, whatever it is, really understanding that and having a really thorough metrification around that input to output expectations and the throughput of each black box. And so that's really our testing strategy, to break it down into the smallest unknown component and really, really understand our interfaces. And by understanding those interfaces, then we can build those back up into leading indicators on safety and performance that are tied into the overall system. And so that's our testing strategy. Now, how do I determine if it's good enough, or how do we as a company there's a whole lot that goes into that. There's the build out of the safety case, which is what everyone focuses on, but there's an operational expectation, regulatory understanding. There's a whole space around delivering a product, and I think Satvir touched on a lot of those things. But going down that path, you have to slowly, inevitably walk up and determine how are we safe enough, which is going to be a company profile depending on your enterprise risk and what you're willing to take on, and really think through what that is. Being good as a human, probably not going to be cutting it anymore with the space and the age that we live in right now, because that's clearly what the media is saying, whether it's for lack of understanding or not seeing the positive gains on the safety side, because I do think we don't celebrate the wins in what we've done that's a lot more safe. Those never get publicized. It's more of the negative side. So building up, what is your expectation? What is our objective on reducing overall risk? How to improve that safety function and formality of, say, our autonomous trucking? And then what do we need to prove and validate that from our standpoint, going down a traditional V model, coming back up, just because you follow every process that's out there or every regulation, as you mentioned. They're not as robust in all these areas. There's a lot of unknowns. So walking down that path is really removing and mitigating every risk that we can. And this is where that ODD design that Satvir is talking about is really, really important. Do we want to handle an unprotected left? Well, in all instances inside of an industry where you're taking a truck, you have to, because they're all in industrial complexes. And how do we design around that, or how do we make that? Is there something we can do from an operational standpoint, say adding reflectors or sensors inside the physical infrastructure? There was mention around how does a city or infrastructure help? That doesn't have to be a smart and connected sensor, but it has to be able to signal and give you information. Those are different ways to design around it. And at the end of the day, it comes down to the risk profile that the company determines or entity that's launching something. Everyone's going to be and want to be safer, and they'll have data that proves it's safer than a human when we do this. Now, educating on what those choices were and how we do it, I think there's a lot of that. I mean, going back to, we didn't used to have to wear seatbelts, and they had them and no one required them, and then it became law. That's actually what instituted it. Or my favorite is actually the reverse camera. They were able to get that down to the lowest cost of, a couple dollars a vehicle, yet it wasn't being put on every vehicle until it became a federal regulation. So I think there's a lot of education on how we're more safe and what areas we are. So we present, we're safer than an average human. That's what every AV company will say. But what you don't see is they've removed more risks than you would ever see as a human, because we already know not to get into those scenarios and stop that. So when there is an accident, it results in, they had an accident, not they stopped 150 accidents that would have happened by a human before they got to that scenario. And more than likely, the AV stack will behave in a safer way than most humans in those, because there's no emotion, there's no initial response or dopamine hit or any of that could potentially change how you operate in those scenarios. So
I'm going to cut in just for one, because I think CJ said something that we also did, is safety cases and another big step. And for every release, we document a safety case, and at least for our driver out, we had a third party review it, because you do want an independent assessment of, what I say is minimum risk makes sense to everybody else. So that's another thing that you also have to, because that gets into your all analysis aspect of it that, I was only talking testing, but thank you for bringing that up.
yeah, and bringing that to just kind of continue on that, it's not just one. So our company built out 3 lines of defense. So we have the product and engineering safety that we build it all. We have a full safety and regulatory one that kind of is like an internal audit, validation, verification to make sure that we don't do anything that's above and beyond or risky, and make sure the risk profile. And then we also use a third party entity to do that. So I think there's a lot more than just saying it's safe enough that goes into launching a product that we definitely don't do a great job of getting out to the industry or even out to the general public when they see one of our vehicles going down the road and they're like, oh, is that really safe or not?
Yeah, no, I think that's a really important point, generating the safety case and having it be, in the absence of regulatory guidance or judicial guidance, right, having the safety case something that can be presented to a third party, with pride, right? Yeah. Yeah, and I think it's also an important point this being better than a human seems no longer to be good enough, right? And the thought experiment we've done a couple of times is to say, okay, there's 40,000 fatalities a year on the road. If we came to everybody and we said, I've got a technology that can eliminate 90% of those fatalities, 36,000 people who will be alive who wouldn't otherwise, everybody would be saying, do that right now, right? But if you flip that around and say, how do you feel about the fact that robots are going to kill 4,000 people a year, right? It becomes a very different discussion, right? And unfortunately, the way our system works, in the absence of regulation, a lot of it gets decided in the court system, and the court system is about that one case. It's not like CJ said, it's not about the 150 people or the 36,000 people you saved, right? And so that is sort of a real fundamental thing for us to grapple with. And I don't know, that was just an editorial comment. I don't know if any of you want to chime in on that.
So maybe I will say one small thing, which is, we do have technology now that isn't autonomous that could drastically reduce the number of fatalities. That is basically checking if someone is actually, driving while drunk, right? That's a perfect example of like something that exists now that could actually prevent a large number of fatalities, but we don't actually have deployed on most vehicles currently. Why not, right? Like that's a thing that, again, to Greg's point, is actually something that we could install right now. There just is no regulation that has made that mandatory. But if we did, that could drastically reduce the number of fatalities. I don't know if it would do 90%, but I think the numbers report something around 50%. So it's a pretty sizable improvement. What I want to point out is maybe the best case for AVs is not the safety case. It's more of the efficiency case. We get caught in the safety discussion, which is something we should be thinking really hard about. But chasing that instead of chasing the efficiency game may not be the best narrative for AVs in general. Just a thought.
Yeah. If I could, I'll just add to what Ram said. I think if you look at this as an opportunity to use AI at the vehicle level, but also at the urban planning and city planning and intercity planning level, then you get some fascinating options that simply have to do with, yes, you can continue marching down the safety path and make improvements, but you can make dramatic improvements in terms of the efficiency with which goods get delivered into towns, cities, and taken out. And so all those transportation-related losses that come because of this inability to think through at that systemic level and make assumptions now, new assumptions around the capabilities of robotic systems and autonomous systems, I think leave a lot of good, positive opportunities that can be acted upon with a combination of private investors and technology and policymakers, I think relatively soon.
Yeah, and I think, focusing on the good we're doing is a good approach, right? And it's actually, Satvir, one of the things I've been impressed with what May Mobility is doing is, May Mobility is funded by cities to make, mobility better, especially for populations that have accessibility challenges. And so, in the event of things going wrong, you can say, okay, but we are making, the community better.
Yeah, I think a good example is Grand Rapids, Minnesota. We have ADA compliant vehicles. Earlier, if you wanted to get an ADA vehicle, you have to put 24 hours request, sometimes more than that, to get a vehicle. And once we started deploying that vehicle, the next challenge for us was the infrastructure was really not designed for loading and offloading. And that's where working with City was actually really good, because they actually modified the stop to make sure that it was ramp loadable. So it's a very small change, but it made a big difference for them. It made a big difference for us. There were areas where we would not localize because it was nothing around there. They actually put some static elements for us so we can localize, because they wanted our autonomy to stay high. So I think small things, but I think this is where working with transit companies, with cities is really beneficial because they understand the needs, they understand the deficiency. They've been doing it for a while. We can drive efficiency into it, and I think this is where it's been really helpful, eye-opening for me at least. I coming from automotive, it was like didn't think about these things, and now it's just completely whole. And same thing. Anything happens, they are our first point of communication, so they know what incident will happen. Incident do happen, and we don't hide. I think the more transparent we are, they can talk to the community. So I think community engagement is really critical. And again, once again, working with the city helps us have another volume voice that helps us. So yeah, I do think it's been really good for us, and very excited to do it more.
Yeah, good. Yeah, and you mentioned transparency, which sort of leads into the next place I wanted to go, which is, and it was discussed a little bit in the panel that we had this morning. Trust in autonomous vehicles is actually declining, right? We saw a presentation from J.D. Power, I think it was on Tuesday at the CCAT conference, where the woman showed that year over year, trust in autonomy was declining within the general public, and when accidents occur, sometimes companies that have intellectual property are less transparent than you would like them to be. I think because they put a lot of work into it and they just don't want to give everything away, right? And so there's this, really important balance point that we need to think about, because of maybe some lack of transparency, trust seems to be declining. How do we handle that going forward? Because ultimately, we can say what we think. I think this is good enough, right? But ultimately, society will determine that, right? Not us. And so that building of trust is really critically important. So maybe give me some thoughts on transparency, and building trust around autonomy.
Okay. It's one of the hardest things that we actually grapple with is how to build that trust, because at the end of the day, none of us, our direct consumers usually aren't an individual or the general public. It's going to be a dedicated either business to business connection, or at the end, and for example, we're going to move goods at a higher rate faster. So you're going to get cheaper delivery on your overnight package because I can run 24 hours a day without the restriction of long haul trucking, which means your dog gets their dog food for 25 cents cheaper the next day versus waiting 3 days. Those things are the value of what it brings, and the efficiencies are really easy to explain. Getting that trust and understanding is because we're in a space where there's a very few individuals in the grand scheme of the general public that understand what is going on and how they operate. So how do we connect and share that? So we have to be very transparent in a way that's understandable. It's not just the transparency, it's an understandable and a storytelling that it brings everyone along at different levels of knowledge and understanding of what it is that a Navy stack does. How do we determine what we see? How do we react to it? What did we do in a case of we were safe stopping here? If there was an incident, this is how it was responding. But it's about being able to educate the general public in a way that allows them to connect it to their understanding of how the world works. So if you explain an accident that I got into an accident because I was T-boned, I went through a green light, someone ran a red light, we can all understand that as a human being. Now, if that same thing happens and an AV gets struck, they're going to ask, well, why was the AV there, even though they were following the rules of the road? Like, there's going to be a little bit more information sharing, or a little bit more to connecting that transparently to understand the actual scenario and connect it back to how a human would understand and operate in those situations. So I think that's at the core of it is how do we tell a story around why it's safe and why it is going to actually add value in everything we do on road or in any other sectors that we bring it, so that it's understandable. Because right now it's an unknown, and change is scary to many, many people. And that's really what we're battling, not the fact that they don't want it. It's they don't understand it, and they can't get any answers when something did happen. Or they get a 47-page dissertation that doesn't actually give you any clarity that the general public can understand.
I also, I mean, to your point, I think one of the things we've done as a community is overselling what this stuff can actually do. Maybe not us, but people who work in this space have generally been like, well, self-driving will be done in 2020, or like we'll be able to have a fleet of 100 million vehicles tomorrow, right? I think generally speaking, that's, not been a credible story, as we've discovered, but has also just left people feeling like, oh, this should have been solved and now it's not solved, so this person and the entire community are filled with liars, right? And so we need to be better and more honest about actually where this stuff stands and actually talk through actually what works in a clean and straightforward way, which is much harder to do. And again, this is why I think emphasizing the efficiency aspects and talking about the limitations when it comes to safety is a much more appropriate story for us to tell. The same thing is true currently with LLMs at the moment. So everyone's overselling what they're capable of. They're saying that they're capable of doing everything. Give us 9 months and we will all learn that they're pretty limited if we don't already know that. They're very powerful. They're going to be a very useful tool, but they're just another hammer in our toolbox. They're not going to be this all-powerful tool that can build every house that exists out there.
So just a couple. Go ahead, Satvir. You want? I think this is fascinating in the following sense, that we are at a juncture where trust in computing has to be fundamentally defined and understood at scale. So it's not just the community that develops these things that understands it, but how we communicate that. On the other dimension, we also have to understand what it means to be ethical in the context of building machines and communicating that. And by ethics, I mean just a simple thing, and that is saying what you're going to do and then doing what you said you'd do. And so can you get that machine to really be ethical in its behavior through human design? And I think these are fundamental questions for which you need benchmarks. You need to be able to measure yourself against these commitments, and those are still not there. So we don't. I don't know if there's someone from NIST here or from NSF. There's been discussions, but really around how when you fill gas and you fill 50 gallons of gas and you pay for it, you know exactly how much you filled and you know what you paid for it. You get the value there. There's trust there. There's ethics there, right? So what is the equivalent when you're building AI systems, especially in the context of autonomous vehicles, but not just in the context of autonomous vehicles. It's really more broadly AI in the context of transportation and everything that we need to do to be able to get from A to B, whether it's people or goods, and come back home safely.
Yeah,
Trust.
For us, it's been just working with the cities as an example. This is one of the things that we are trying to do for our Detroit launch that is coming up soon. We worked with Mcity and we worked with ACM independently to validate our vehicle. We just provided a vehicle and a driver and said, let's do your driver testing, and because that was critical for them to understand, can it do these basic things, because those were the things that they learned from their community that they were concerned about. And then we're always presenting information, but like CJ mentioned, it's like, for me, I would probably get into 100 pages of detail, which somebody who's just wants to understand what is going on at a basic level. So we do have community engagements, and we usually try to, wherever we launch, we have a local site and we hire locally. So those people actually become our customer success, kind of just try to understand what are the needs. It is still difficult. I think we're trying to solve it slowly, but it does need time as well. Sometimes it's the more you ride it, then you start to understand, okay, that jerk was okay. I'm just, the first time you ride it, it's just like, it feels like, why is it doing this thing? So I do think time would also help, get that in as well. So.
Yeah, it's an interesting point. I mean, we've all been trained as engineers, not as storytellers, right? Yeah. But there is a story to tell, and it would appear that, from the JD Power results, that it's not getting told well enough, right? And one of the things, I actually was fortunate enough to sit next to Ed Olson, the CEO of May Mobility, on Monday night at the speakers dinner. And he mentioned that, transparency is sort of built into the model at May Mobility, right? Because your client, the city, gets feeds directly from all the vehicles. So there's not this question of, can you produce the video or not, right? It's like the video's already in the client's hands instantaneously, right?
All our sites have, you can see what's going on in every vehicle, and that log gets locally, and some of our cities have full access to that, and then we can get into with our tools and show them more detailed. But I think that is one of the other aspects, is what also very critical for them to see. Yes, we're not trying to hide anything. We'll be at fault sometimes. So my goal is to reduce it as much as possible.
Yeah.
But you can't. There is no. I can't 100% say driving back home I won't have anything happen today to me either. So
Okay, last question for me, and then we're going to open it up to audience questions. So, in the absence of regulatory frameworks that we can point to for how good is good enough, the reality is we'll probably have to present those cases in the judicial system, right? And so how has that, affected, and especially in an AI context, right? How has that, the fact that you may need to go explain that, in a courtroom, right? How has that changed your approach to determining safety? Or not?
Or not.
Yeah.
I don't know that it's changed it. I think it's bringing a new level of scrutiny, and we're bringing, no one ever gets into this industry not to do it safe, right? So everything we always have, everyone's predicted on, and everyone believes it's safe or safe enough to deliver what they want to do. Bringing in that regulatory or that concern is, we put a really big focus on a safety and regulatory organization that's separate from engineering and product for that specific reason, so that we have, 4 eyes process that can come in and can review and look just abstractly to give you a different lens. So they're going to be experts in regulatory counsel, all that kind of stuff that then says, this is how it's looked at, this is our understanding, this is how we would walk down it if something did happen. So it allows us to bring a new aspect. I think a lot of companies are doing that now based on recent revelations around what's happening in the industry. Not that anyone's doing anything different from an engineering standpoint specifically. I think bringing that value in earlier is starting. You're seeing a lot more of that. So it's a very highly sought after skill set to walk in and kind of help decompose and break that down from a legal standpoint, from a regulatory standpoint, and a safety standpoint, independent of how the engineers believe they're implementing it. It's a really good opportunity for us as a lessons learned to really actually bring that in, and so we can have those kind of, go back to our high school times, a mock trial type incident to kind of go through what were these scenarios and use cases, do case studies internally before we'd even get there, so we are prepared. That's a lot of these failures that you see in the media aren't because they didn't try to do the right thing. It's they didn't know what was going to happen. They didn't know how to interact with a judicial system or regulatory bodies. And so they thought they were giving everything by, for example, showing all the video, but not having a commentator to explain what they're seeing, what was amiss. If they're not trained to have that communication, we really focus on bringing that in earlier now in our product requirements, system requirements, into our design. And then we actually validate that through case studies on the backside too.
Yeah, I actually think there are, quite a bit of standards that are already out there, like, UL 4600, there are AVSC has, so we're already trying to, that's the safety case we built around it, and we had our safety case assessed against. So our approach is we're going to go after state of the art safety standard out there. We're going to comply to it. We're going to win compliance against it. We will have an assessment against it to make sure we're coming out there. I think it's the same process that happened in automotive. It took ISO 262 a little bit of time before it became everybody wanted it, right? For sometimes, there was 61 5 that was being done earlier, but so I do think the regulations will come. But for us, there are out of standards are already out there that we're using as our guidance to build our safety case around it, and the best we can do is what's available out to us, and find the known situations, limit the unknown as much as you can. So
At refraction, you're dealing with it by staying 8 miles an hour and 30 pounds or something, right?
No, I mean, we have similar safety assessment and whatnot that these, folks are describing. Yeah, I mean, in terms of, the question that you're asking, in terms of getting ahead of sort of a judicial process thing, I think, we have these standards that we can try to, assess ourselves against, but trying to tell a good story about it or a clean story that the public can understand is a much different challenge, right? So, I mean, I think that's something that everyone in the room should be thinking about. How do you actually communicate what you're actually working on in a way that's understandable? And I mean, that ultimately, I think, is one of the hardest challenges when it comes to safety. What does it actually mean to be safe is a thing that, I think is at the kernel of this panel. We're all struggling to answer that question in a concise way. Is it being as safe as a human? Is it being more safe? What does that actually translate into? These are hard questions, right? And that's something that we think really hard about, personally and at Refraction too.
All right, so now we will throw it open to the floor. Anybody have a question for our panelists? See one here.
Thank you. That was an excellent panel. I wanted to jump off the last question. So my name is Nick Xenakis. I'm a lawyer, which is sad. And I know. I think that last point is something that has been on my mind a lot as well. The law can be really bad in this sort of space where it's just one instance that helps define what happens next. And so, from all of you who are deeply involved in this, talking to counsel, talking to regulatory counsel, what would be the most helpful thing? Is there a helpful thing the law could do? And is there something even happening right now that could be helpful? And the answer could be no, but we'd love to hear.
There's actually quite a few committees that we have people that are part of that are regulatory bodies that are connecting directly with the legal side and industry experts. I think trying to share best practices, share that understanding. Typically what we run into, though, is a lot of folks on the lawmaking side and that aren't understanding they don't understand some of the deep technology to determine what is safe, not safe. Is it the right choice? How do we over-index? So they come up with a lot of their solutions or mitigations are for humans, but our systems don't have a human in it, which means having a bunch of telltales inside of a cluster in a truck, that's not so valuable to a computer. There's different ways to do that and regulate that. I think being able to ask why, to understand, and then connect it back to the actual root cause or the problem that we're trying to solve from a law standpoint, that's when we get into those active conversations and we're proactively saying, before we get into an incident, we're proactively getting into what is it that we're trying to solve for? What are we concerned about? Is it the general public? Is it we don't know how to handle a certain scenario around regulation or how an incident should work or respond in case, for example, if it's a robot, how does a police officer approach it? How are they connecting to it? We're doing a lot of that with those entities and figuring out what is a good use case and that kind of stuff, but bringing that to a bigger, broader board to help regulatory understand it, because law officers in Texas have completely different ideas than law officers in California on how to approach this, and we get very dramatically different responses. And so commonizing that in a way that's least impactful to drive really, really finite regulations, but setting it up to have expectations that can then be regional specific are probably the biggest opportunity to help us.
Just a couple of comments. I think policy generally tends to lag technology. This is just historically shown. And then law tends to be on the conservative side for all good reasons. And by conservative side, I mean for safety, and if you don't understand anything else, no matter what the laws of physics say, you have to have stopped. You ought to have not crossed the line. I think what we have is a fantastic opportunity to look at where we don't overregulate and have the burden of all responsibility placed on the innovator or the developer, because that'll stifle growth and innovation, right? So I think what we have here, I'm just looking at ourselves here, and I think you architected this really well, Greg, from a Newtonian physics standpoint, because you have a 10 kilogram, roughly order of magnitude, sort of Newtonian physics fenced movement here at 8 miles an hour. And then you have a order of 100 to maybe 1,000 kilograms, laws of physics they're working at still relatively slow speeds. And then you have, of course, an order of thousands, tens of thousands, heavy-duty trucks here. And I'm a 0 kilogram, 0 mile per hour person sitting in where I am. So I think there's an opportunity here to look at where policymaking and therefore lawmaking and changes in even evidence gathering and discovery can happen in these various sandboxed or geofenced contexts. And I think that's where the big opportunity is. It's a great time in our journey as human beings here to now look at new rulemaking that comes from this kind of massive data gathering that's happening with AI and the selective and focused data gathering opportunity we have to sense the real world in a system of systems context, and then say, okay, what's in the best interest of society, and what's in the best interest of serving justice in a broader sense.
Hi, Nick Morrison, Center for Entrepreneurship. I appreciate all the comments by the panel. And driving in today, have to be reminded, it is construction season here in Michigan. And it always brings my mind to the concept of safety, AI, autonomy in vehicles. And I'm curious about your opinions or pontifications if we're going to reach a set of milestones or thresholds at which safety as the main driver for the adoption, the wider adoption of these technologies, takes place because of the built environment design or because of the compute and the design of the behavior of the vehicle itself.
Just for some clarification, you're trying to understand, is it the infrastructure or the external that would potentially be limiting, or the power and capability of our internal product and stack and build?
Right. Do you see any thresholds or milestones that we would hit in terms of either the brains of the vehicles and the computational capacity of the vehicles, what they're considering, the data that goes into that? Or is it that at some point we reach a threshold where the emphasis should be placed on the design of the environment in order to allow for the safety considerations of the vehicles to actually be realized?
Oh, okay. Now with that clarity, that's a really good question. And I don't know that'll be the best answer, but I can give it from our aspect. I think it's got to be both right now. I don't think one or the other. I think we are solving, a lot of times we're solving the same problem, and there's two ways. Like, those are two different distinctly opportunities to solve the problem. We have to handle that because we're not going to get a standard regulatory setup that state to state, region to region, it's specifically designed in a safe way or a specific way to give us the triggers or opportunity for us to route and navigate through. So we have to handle that uncertainty, and we're going to have to do that with the design in the vehicle. We get to see it a lot. We're an international company, so if I say go over to Germany, it's very regulated on how they put up construction and they do stuff. It's all broadcast ahead of time. You clearly know what route will have it. It's very dedicated, shut down, change. That helps with a lot of planning and route planning ahead of time and predictive models, whereas in the US, there might not ever be a mention from anything on the regulatory side from that city or that township, and they'll just shut a road down as a reactionary thing to a bridge or any of those things. I would say both of them need to give us an option, and I think that's where, as you get into safe operation, we really have choices in mitigating the risk across not only how the infrastructure is designed, Also, we can start to use regulations around where and what time operations could happen in certain regions, or traffic patterns, or extend all that to every variable or parameter you want. And then we have to handle that on an AV stack for the unknown. Like that's the goal, is to handle the unknown. That's what we do as a human when we're driving, is we come up to, well, there's no painting on the road, there's no signs, there's no nothing, and I got a tractor coming down the road at me that's 8 times the size of me. What should I do? And we have to handle those scenarios. So I don't think you can regulate or design around all of them. I think you can make a lot more of them much easier and safer, and I would say that's not even an AV space. I think we could design a lot of our infrastructure and that around it just for humans and, say, construction in this one, the construction workers to be safer.
I had a sort of a comment. Maybe this might help sort of clarify the question too. There's been several specific use cases around, say, AVs stopping, or I should say, real world scenarios where autonomous vehicles have stopped because they're waiting to pick up a passenger, and a first responder or 2 or 3 first responder vehicles are waiting behind, trying to go past that autonomous vehicle. And so these are cases where there's clearly a wake-up call for the joint design between the autonomous vehicle and the built environment. I think, so we're getting several different very specific, these examples were in the city of San Francisco. There's been cases elsewhere too. So I think where we are at is a very good opportunity to co-design the interaction between the built environment and autonomous vehicles. Most of the roadways were built for the absolute perfect, undistracted, ever undistracted driver. And that's not the real world in which we live, even with human drivers. And so I think regardless of AV, there's an opportunity to use the power of AI or other tools to be able to design a better built infrastructure. And in the context of AVs, this becomes an even bigger opportunity.
Yeah, like I was saying in the Swiss model cheese, I think today the cheese of infrastructure is missing, and you can make it really good. So think about not to pick on buses, but those do offer interesting. We see that a lot in our Ann Arbor driving. You can come and vehicle would stop at a line, but it's not enough for a bus to turn. So we have to take over and back up, right? So it's a very small change that, if you could make that, would make a lot of things safe, predictable. Same thing with constructions. I think we also operate in Japan, and we have a very good understanding of what's coming through. But over here, it's not as bad because city does let us know what's coming up. So we do get some, ahead of time, but you still end into surprise because anybody can put a cone in a street here and be okay and do their thing. So those are the things that we definitely at some point will have to say, okay, we've saturated the vehicle aspect of it. Let's work on the infrastructure slice.
And Satvir, my guess would be that May Mobility chose Sun City, Arizona, because that's a built environment that's very amenable to autonomy, right?
Yeah, I think it was wider lanes. It just helps us simplify
Better
our
weather.
ODD. Yeah, so make sure. But we're looking at to now complex sites because now we've tested it. Now we have to get more.
I wanted to kind of touch on one topic that was discussed today, which is benchmarks. We do have quite a few different benchmarks for developing and designing algorithms for autonomous vehicles. There's almost none that I'm aware of that's focused on evaluating these autonomy stacks for safety. Is there a reason why, and would that be actually helpful to build such a benchmark through the community?
Maybe I could ask a follow-up question, which is, so certainly there are benchmarks out there that are assessing different modules and assessing the quality of performance of those different modules. So, Kitty, for example, is a data set that's available that assesses, your performance on object detection or your localization performance. There's also motion planning benchmarks that assess your quality of like performing safely in different types of contexts, right? So I think it's called Open Streets, which is put out by the University TU Munich, who they have a bunch of work on basically assessing your ability to travel through different intersections and whatnot. So I do think that exists, but maybe I'm not understanding the question fully.
Yeah, so my question was mostly around the system level kind of assessment of the autonomy. Mostly if you're driving around with other humans on the same road, how do you evaluate the safety of the algorithm, the full stack?
I think there are systems out there that are assessing your full stack, but they're not assessing modules at a time. They're just taking in an entire input and then assessing if you actually perform safely in terms of motion planning for the entire, so for example, there are benchmarks out there using Carla that basically take in camera and LiDAR information and then ask you to generate a motion planning trajectory and then assess if that motion planning trajectory actually gets you to your goal. So those do exist. They're not very popular, I would say, but they are used in the academic community to assess your safety.
So Ram, maybe this is the question maybe is on the practice side. Right? Can you actually drive a vehicle through and you get a smog test and you say you're good to go? Can you drive your vehicle through and you get an AV rating and you say, okay, well, you're not good to go, fix your code, come back, or you're good to go, carry on. So I mean, that kind of you're probably a few steps away from being able to get that kind of a benefit. But I think it's a valid question, and I think where we are might help.
I think a lot of the reason you're not going to see what you would expect where it's validated and give it as a liability.
Yeah.
Because if someone says that they'll give me a model and all I got to do is pass that and I get a
That's
certification,
right. There's the other side.
that takes a whole lot of liability off my organization to say, no, we did exactly what you asked us to do. And that's where I don't think you'll see that become an industry standard or a regulatory body, because it starts to shift liability from the owner operator, in this case us as the developer, to a regulatory body that then has to answer it. And that's probably the biggest hurdle that I would see, is because liability and all these things, whether it's us as a software stack that goes on a Daimler truck, we're still struggling with liability between the two companies and how we bring it to market in some sense, let alone adding in, all I got to do is validate through a third party and say, now they have full liability because I passed every test with flying colors through theirs, and then the first time we have an incident. So kind of goes back to the judicial instances where that will decide everything. But I would guess that's why you don't see any, standardized regulations around that or opportunity for us, simply because I don't know that anyone would generate it to say that they would love to take the liability for every AV stack.
And I mean, to even broaden that, the only person who could probably do this is a regulatory agency. And you can understand the problems that they would have doing that, which gets back to the question that was asked earlier. What could be done to benefit all of us? It's like if a regulatory agency could actually figure out what the right type of testing would be. But that's also kind of an open question in the research community, I think.
I think so, yeah.
Henry has a beautiful, demonstration outside where he's looked at this kind of thing when it comes to, looking at roundabouts and these other kinds of, testing scenarios. But doing this more broadly for all sorts of driving, it's pretty difficult. What does that actually look like? Yeah.
Yeah, I think traditionally it's been done in the physical world, where the laws of physics are what you have to comply with, or in the chemical world where you measure something. I think in the computational world, this is still terra incognita and a lot of unknowns here.
Plus, I think your ODD is so different, even just in our division, what Waymo is, what Cruise was, what we are, it just would be very difficult to wrap that around it, because today I'm in Anand, but tomorrow I could be in, somewhere in Florida, or, hopefully one day in Hawaii, but you just don't, it would be just difficult to predict that, ODD covers all of this. So like if I'm thinking like I'm trying to make an argument from a safety point of view that I have complete coverage through this, and that would be a very difficult question to answer from a off-the-shelf kind of solution.
Okay, my watch says we're at 2:40. So I guess I would like to thank our panelists for a really great discussion. Let's give them a round of applause. And as was mentioned, there are 2 display monitors out in the lobby where we're showing some different projects we're doing at Mcity. One is on depot autonomy, where we're taking basically L2 type ADAS-equipped censored vehicles and using infrastructure to help them, autonomously maneuver through depots. And the other monitor's got our Mcity 2.0 work, which we're doing with the National Science Foundation to make our proving ground digitally twinned and available to remote researchers anywhere across the country, as well as the AV Challenge that Mcity is sponsoring, and the AI data engine that we're using to create better and better AI algorithms going forward. So, feel free to make sure you stop by and look at the discussions that are on the monitors there.